Mr. Minnick helping my students with this worksheet right here, number 2, tracing if statements. And I already built a truth table for you that we're going to use as a guide. Here goes, number 1. If num is greater than 5, I want you to plug it in here to this empty control expression and see what happens. So with pencil, please, num greater than 5 written in there. Okay, num equals 5. Well, num is the variable, and it's equal to 5 on this worksheet. Other is a variable, it's equal to 10, and we'll use it later, but the variable foo is equal to -3. So when you get to this point in the little code segment, is num greater than 5? Yes, it is. So this is true. And if an if statement is true, that means the top part of it executes. We'll talk about the other part later. So it does say true, and therefore the answer to number 1, the T should be circled. Let's move on. Number 2. Well, to do number 2, I guess we have to erase our pencil there because that's just what we have to do. And number 2 tells you to plug in this longer thing, which I'm not going to keep rewriting, but this longer control expression, pretend it's in there. So if num is greater than or equal to 5, well, on this whole worksheet, num is always 5. So we are really asking the question, is num greater than or equal to 5? Well, who wants to be famous? Tell me, is this true or false? John?
It is true.
Correct. So put a little T there in pencil to show me that you know what you're doing on this worksheet. Your scratch work should be written in. Okay, somebody else. Is other less than 11? Yeah, Lauren?
True.
Correct. So put a little T there. Now the tricky part. What do you get with strict parent when you have an if statement and the part in front of the and is a true and the part after the and is also a true? Does the strict parent overall say true or false? Well, let's come down here to our truth chart. Strict parent is and we have the situation here right now of a true anded with a true. Oh, the answer is 1, which is another fancy way of saying true. So the answer number 2 is true. Hey, here's another little trick. And is like multiplication. And or is like addition in the world of computer electronics. And 0 times 0 is 0, 0 times 1 is 0, etc. So and 1 times 1 is 1. Now or is like addition. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0 is 1. And to a computer, which never heard of the numbers 2 through 9, computers only know binary. Only zeros and ones work in the computer. So to a computer, a 1 plus a 1 is a 1. The light switch is either on or off. There's no level 2 on a normal light switch. And that's the way computers are wired, including iPhones, and that's the way it'll always be. Until Mr. Zhao, you invent a ternary circuit instead of a binary circuit. 3-way instead of a 2-way, which I think they're working on, but maybe you can help fix that so that computers are twice as powerful in 30 years than they are today. That would be cool. Anyway, back to problem number 3 now. No, yeah, let's do number 3 because that has a not equal to symbol in it. On a math test, you would do this meaning not equal to. But since there's no key on the keyboard like this, to represent not equal to-ness in Visual Basic, you type a less than and a greater than. Okay, so let's do number 3 together. Is foo, true or false now, is foo not equal to -1 on this worksheet? Tyler, true or false? Foo not equal to -1. Good job, true, he said. Good job. It's a little t. Okay, other less than 0. Is this little part true or false? Nigeli? Correct, false. So, because 10 is not less than 0. Now, what do you get down here on your truth chart when you have a true ORed with a false? Well, don't even look at the truth chart. Let's just think of that plus as that OR as a plus. What do you get when you have a 1 plus a 0? Oh, 1. Which is a true. Ones are trues. So you could just do math on this worksheet, or you could just refer to the truth table. Okay, skipping ahead because I don't want to do all of these for you. Let's do one with mod. Now, there's only one mod problem, so I'm going to let that separate the A's from the B's. Mod, look it up in my old lecture notes. It has something to do with the the remainder to a division problem. Also, be careful with the parentheses. You got to always work from inside the parentheses out. So right here we have an outer set of parentheses forcing you to do all of this side before you evaluate the true or falseness of this. And that's about it, I think, with number 14. I talked at length about this on the previous video for the previous worksheet. So you rewatch that video. I don't want to make this video longer. Good luck, everyone.